guys, in previous classes already we have studied about the structure of an atom by using the Thomson model. Thomson gives his ideas about the structure of an atom, like the atom is spherical in nature and the protons are uniformly distributed in an atom and the electrons are embedded in nature. But he fails to explain some certain science experiments in forward steps. That's why the next idea will give, or we give the ideas by the Rutherford model. The Rutherford model. In today's class, I wish to explain about this Rutherford nuclear model. Rutherford nuclear model. By alpha scattering experiment. By alpha scattering experiment. I hope you know the meaning of the scattering here. The scattering means that something comes to strike one object and it gets deviated or it gets deflected. Then it's called as a scattering. So alpha scattering experiment means by the help of the alpha particles and the observation of their scattering, the Rutherford conclude his ideas about the structure of an atom. So what is the experimental setup here? Just let me show here. He take one alpha particle source. This is our alpha particle source. Alpha particle source. And next, adjust one lead foil here, having a middle one hole to pass the rays of an alpha particles. To pass the rays of an alpha particles. So this is a lead sheet. And next, put it the gold foil, which is surrounded by the photographic sheet, So this is our photographic sheet made by this fluorescent material. This photographic sheet is made by the fluorescent material like a zinc sulfide. Already I told you in a cathode ray discharge tube, then also he coated the fluorescent material like a zinc sulfide. So what he does, the zinc sulfide coated in photographic sheet, it start glows when something strike on it. And next he put it a gold foil. So this is the experimental setup of alpha scattering experiment in Rutherford model. Then what happens, see here, when the alpha particle rays comes and hit to the gold foil and then what happened, the most of alpha particles goes in a straight line. The most of the alpha particles goes in a straight line. They are undeflected. They are not deviated. So what happened? The most of rays are undeflected. Undeflected means they are going in a straight line. They move in a straight line. Undeflected. Or they moves in straight line. And next, the sum of the rays are deviated. The sum of the rays are deviated in certain angles. So what happened in the next case? The sum of the rays are deviated. Some of the rays are deviated in a small angles, or some of the rays are deviated in a larger angle. And next, the third one is the sum of the rays are get hit back nearly 180 degree. Nearly 180 degree, some of the rays are strike and comes back. So some of the rays comes back. So see here, by seeing these observation, just he observe and just he guess what happened. Why some rays are move in a straight line, why some rays are get deflected in a smaller angle, why some rays are deflected in a larger angle, why some are get back. Just he think and he observe the most of space is empty in an atom. The most of empty space present in an atom. So what he observed? Let me write here. What he observed? The most of space, the most of empty space, the most of empty space present in an atom, present in an atom. Why he observed this? Why he expected the most of the empty space present in an atom? Because the most of the rays are without deviating and they are undeflecting. They move straight. That's why he observed the most of space is empty space present in an atom. And next one is some of the rays are deflected and deviated. So he think there is a certain mass is there. The most often mass is concentrated in some region in an atom and it is a positively charged in nature. Why he think like this? Because already you know that opposite charges are attracted to each other and same charges are deflect, same charges are repulsive each other. The opposite charges are attracted to each other. The alpha particles are positively in a nature. When they are going near to that concentrated mass, then they are get repulsed. So see here, I explain with the one diagram. There is a certain mass. When the rays are comes here, so the lot of empty space in an atom. That's why these rays goes in a straight line. The most of the rays moves in a straight line, and then some rays comes which is near to this concentrated mass. So then what happened? They are repulsive each other. This ray and this mass is repulsive each other. Then it deflect in certain angles which is very nearly to this. It is deflected or it is reflect in a larger angle. So like this, some of the rays are deviated by the repulsive force. So like this. And then some of the rays are directly hit to this concentrated mass. Directly hit. It is heavy in nature. By the reason of this heaviness, again the particles comes back nearly to the 180 degree. So like this, rays are behavior by the reason of this concentrated heavy mass present in an atom. So he observed the 2 points. By observing the 2 points, by observing these rays travelling nature, he conclude some points. I wish to tell here. His conclusion is the positive charge and most of the mass of the atom was densely concentrated in extremely a small region. In extremely a small region. So this very small portion of an atom is called as a nucleus. So here he told to us it is a nucleus, sorry, it is an atom. At the center, very densely, heavily, the concentrated mass is there. It is very small. It is very small portion. So it is called as a nucleus. Just you imagine this is your cricket ground which is having its radius of 5 km. Wherever it go, it is all 5 kilometers. In the some cricket ball is put it at the center of that ground. Put it at the center of this ground. So such a small portion is called as a nucleus. So once again I repeat here, the positive charge and the most of the mass of an atom was densely concentrated and it is extremely small in nature, and this very small portion is called as a nucleus. So first conclusion point of the Rutherford model. And next what he conclude, see here, the nucleus is surrounded by the electrons. This nucleus is surrounded by the electrons that moves around the nucleus with a very high speed in a circular path called as an orbit. Let us see here, these are the circular paths. These are the circular paths. In this circular paths, the electrons moves around this nucleus in a high speed. Just imagine our solar system. So our earth is surrounded and moves around the sun. So like our solar system, in a circular orbits, the electrons moves around the nucleus. So these circular path is called as an orbits. His second conclusion is the electrons are surrounded by the nucleus in a circular path, and that circular path is called as an orbits. And then third one is electrons and the nucleus are held together by the electrostatic force of attraction. I already told you the nucleus is a positively charged, heavy and heavily concentrated portion which is at the center of an atom, and next the electrons are negative in nature. Obviously the positive charge and the negative charge get attracted to each other, have a force of attraction to each other. By this force of attraction is called as an electrostatic force of attraction. These are held together with the help of this force of attraction. So this is his third conclusion. Just once I wish to recap. The positive charge and the most of the mass of an atom. The positive charge and the most of the mass of an atom heavily concentrated at the center of the atom called as a nucleus, and the electrons are surrounded by this nucleus in a particular circular path, and that circular path is known as an orbits, and the nucleus and electrons are held together with the help of electrostatic force of an attraction. So this is our Rutherford model.